Hi viewers, welcome to Sai Praveen channel. In this video, we are going to learn about the parallel connections. What is that? Parallel circuits or current divider circuit. In the previous video, we are discussing about the series connection or voltage divider circuit. In this video, we are going to learn about the another method, parallel circuits or current divider circuit. So in the previous video, we will see the series connection, how the resistive elements are connected in series. In this video, we are going to see how the resistive elements are connected in parallel. Let us see. Plus minus voltage source and so on. Rn, R1, R2, R3 and so on Rn. So from this the circuit, the current is I here, and in this branch current is I1, in this branch current is I2, and in this branch current is I3, and in this branch current is IN. So here this is a parallel connected circuit. In the previous video, if you see how the series connected circuit, the positive terminal of the first element is connected, negative terminal of the first element is connected to the positive terminal of the second element. Here see all the positive terminals, plus minus, plus minus, plus minus. If you observe here, all the positive terminals are connected to one end and all the negative terminals are connected to another end. So this type of connection is known as a parallel connection. And here see, in the previous video the voltage is divided V1, V2, V3 like that. Here the current is divided I1, I2, I3, IN. So what are the resistors here we are connected? R1, R2, R3 and so on Rn. These are the resistive elements connected in parallel. So what are the current divides? I1, I2, I3, IN. Like how in Kirchhoff's voltage law, like how in series circuit we are applying Kirchhoff's voltage law, like that here if a circuit is connected in parallel, to find the current or voltage through it, it is easy to find out in Kirchhoff's current law. What is that? Kirchhoff's current law. So apply that one. Apply KCL, Kirchhoff's current law, to the above circuit. What it will become? So see here, what is the Kirchhoff's current law statement? The sum of the currents entering at a node is equals to sum of the currents leaving from the node. See, if you see, current entering to this node is I and current leaving from this node is I1, I2, I3. Is it right? So, and IN also. So, we are going to apply the KVL. From that, sum of the currents entering at a node I is equals to I1 plus I2 plus I3 plus and so on plus IN. Here already in the previous video we will said that in series current is same and in parallel circuit voltage is same. So it is a parallel circuit, so voltage across each and every element is V. You are considering voltage across each and every element is V, but the current is different. The current is divided here. That's why we call this as a current divider rule. Okay, if you observe here, then what happened? So Vs, all elements has a voltage. same voltage across the elements. Now, what is this I? So, we know that from Ohm's law, V is equals to IR, I is equals to V by R. Is it right? So, from this we can write I1 equal to V by R1. Why? Because voltage across the R1 resistor is V and the resistor is R1. That's why V by R1. As I tell in the previous video, if you apply KVL, the equation should be in the form of I or V by R. Like this. V by R1 plus I2. V by R2 plus I3. V by R3 plus and so on plus V by Rn. Let it be equation number 1. Let this one be equation number 2. Very simple. If it is a voltage equation, it should be in voltage or IR. It should be a current equation, it should be in the form of I or V by R. This is the very simple thing. It is a voltage equation, V or IR. Now, I is equals to, if you take all the V terms common, what happen? If you take all the V terms common, it will become 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. This is the equation number 3. So, I can be written as I is equals to V by R equivalent. Then what happened? V by R equivalent. V or Vs, no problem. We can, for our notation purpose, we are considering it as voltage source. You can write it as Vs, V, no problem, V. So, V by R equivalent is equals to V into 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. Let it be equation number 4. V gets cancelled, then finally we get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn, R equivalent. Okay, 1 by. So, this is the equation for the resistors when they are connected in parallel like this. So, we know that R is the resistance, R is resistance. What about 1 by R? 1 by R is the conductance and it is denoted with G. We call it as conductance and its units is mho. The units for resistance is ohm and the units for the conductance is mho or Siemens, S-E-M-E-N-S, Siemens S. You can take anything. So, if you want to write this equation in conductance method, then G equivalent is equals to G1 plus G2 plus G3 plus and so on plus Gn. That's it. If you want to find the R equivalent, then it will become 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. Okay, this is the thing. If you connected only two resistors in parallel, then we have a formula. In many of the cases, the circuits have only two resistors connected in parallel or two resistors connected in series. In that case, if it is a series circuit, you can easily add all the resistors present in it and you can tell the answer. But coming to the parallel connection, it will give a formula that 1 by R is equals to 1 by R1 plus 1 by R2. Now, do what happen? It will become R1 plus R2. 1 by R is equals to. So, if you want R, you can reverse it. R1 R2 by R1 plus R2. That is direct formula to find when two resistors are connected in parallel. This is the easiest method. Okay, this is all about the parallel connected circuits. Very simple. You have to remember only two things. If it is a voltage equation, the equation should be in the form of voltage or IR. It is the only thing. If it is a current equation, the equation should be in the form of I or V by R. Very, very simple. If you remember this one and this one, the solving of the circuits is very easy. Keep remember these two things and type of connections. Okay. And one more thing, if it is a series circuit, voltage is divided. If it is a parallel circuit, current is divided. So this is all about the series and parallel connection of the resistive element. Okay. Keep watching. Thanks for watching.